Okay, everyone. So in this video, we are going to focus on pH. This is going to be our acids and bases video part number 2. So pH stands for potential hydrogen. And what this means is that our pH number is going to measure the amount of H plus or protons in a solution. And the calculation for pH is equal to the negative log of H plus concentration, or the molarity of hydrogen. Now, if you remember this from math, which I know a lot of you are groaning in your brain thinking, oh, math, don't worry, you don't actually have to do the calculations, but you do need to remember a little bit about logs. Logs kind of have an interesting inverse effect. So this means that something with a high H plus concentration will actually have a low pH number. So if the H plus concentration is high, the pH is low. So this is considered an inverse relationship, or another way of saying it would be an indirect relationship, because what one does, the other does the opposite. Now, pOH is very similar, except instead of measuring hydrogen, pOH stands for potential hydroxide, meaning that it is measuring the amount of hydroxide ions in a solution. And your pH numbers give you a scale. And our pH scale is something that you should remember from physical science, but the pH scale goes from 0 to 14. And 7 is our middle, and it is our neutral area. So anything that is lower than 7 is going to be an acid. So acids are from 0 to 7, and bases are from 7 to 14. Now, the closer you are to 0 or 14, the stronger you are. So if you have something that's a pH between 11 and 14, so say 12, 13, something like that, that would be considered a pretty strong base. But if you have something between 7 and 11, so pH of 8, 9, 10, those would be considered weaker bases or weaker solutions. They just might not be as heavily concentrated. But with acids, the opposite is also true. With acids, the lower you are, the stronger you are. So if you have something with a pH of 1 or 2, you're going to have a very strong acidic solution, whereas if you have a pH between 3 and 7, so 4, 5, 6, that would be a weaker acidic solution. And so this pH scale is how we use to measure very quickly the strength of an acid or a base in that solution. Now, a solution with a H plus concentration of 1 times 10 to the negative 4 will have a pH of 4. Okay, but a solution with an H plus concentration of 1 times 10 to the negative 5 will have a pH of 5. And so the thing that I want you to understand is the relationship between the relative exponent and the pH, assuming that the number in front is a 1. But if you have something that's times 10 to the negative 4 H plus concentration, your pH will be around 4. So for example, if instead of 1 times 10 to the negative 4, you had 2 times 10 to the negative 4, it would still be around a pH of 4. It would just maybe be like 4.2 or 4.3, and not exactly 4. Same thing with a pH of 5 if it's 1 times 10 to the negative 5. But when you're looking at scientific notation, it's important to remember that a negative exponent means that the decimal moves to the left. So, for example, if we have the number 1 times 10 to the negative 4, we move our decimal over to the left 4 times. So 1, 2, 3, 4. So that would be 0.0001 moles of H+, whereas 1 times 10 to the negative 5 would be 0.1234 decimals over. And so that means that this number here is actually the bigger number than 1 times 10 to the negative 5. Even though the number 5 is bigger, a larger negative number actually means that it's small. So keep that in mind. And so that means if you have a solution that has a pH of 4 and it's going to have an H+ concentration that is 100 times stronger than a solution with a pH of 6, because we know that on the pH scale a pH of 4 is going to be stronger than a pH of 6, but how much stronger? Well, it'll be 100 times because you would move your decimal 2 times. So every time you move pHs, it gets another factor of 10. So for example, if we had something that was a pH of 4 and something that was a pH of 7. In order to go from 4 to 7 on a number line, you have to go between 5 and 6. So if you count that, it would be moving 1, well, let's count the opposite way. It would be 1, 2, 3. So that's a factor of 10, a factor of 10, and a factor of 10. And so we could say that a pH of 4 is 1,000 times stronger than a pH of 7. And that's because every time you change pHs, you're changing by a factor of 10. This is kind of how logarithms work. As a little side note. And so you kind of want to keep this in mind, and we'll do some more with the pH scale, but you really want to just understand where acids and bases are on the scale and what that looks like, keeping in mind that if you have something that's at a 0, you're going to have something with a high concentration of hydrogen ions or hydronium, whereas if you have a pH of 14, that means you have a low concentration of hydronium.